Hi folks, it's John from the West Virginia Robotics Alliance, and this is our compact VEX IQ sizing tool. So as the name implies, the primary advantage of this tool, or the reason we designed it, is that it is more compact than the official sizing tool. The official sizing tool you can buy from VEX sits on 4 tiles, and this one sits on 2 tiles, so it's half the size, and that makes it a lot easier to transport, and it sits a little bit nicer on a table. However, it works pretty differently from the official sizing tool. So in this video, I'm going to talk about how we use it to size VEX IQ robots, and also a little bit about how it goes together. So first, using it. So whereas the official tool is kind of a frame that you slide the robot through, this is a tub that you put the robot in to verify the size. And obviously the interior dimensions of this tub are 11 inches in this direction and 20 inches in this direction. And those are the horizontal size limits in the VEX IQ competition, at least usually and this year. So here's a robot, and we'll set it in the tool. And so here we can see that the base of the robot is in size. And obviously, if we look at it from the top down, we can verify that everything is in size here. Now, there are 2 other things that we might often want to check. The first is the height. We want to make sure the robot is within the height limit, 15 inches. And number 2 is we want to make sure that the robot remains in size horizontally throughout its full range of motion of any mechanisms that might move outside the size limit. And we can verify both of those things with what I'm calling the height tool. So the height tool, first of all, is 15 inches tall. So if we just set it down next to the tallest part of the robot here, we can verify that the entire robot is under the height limit, obviously this one by quite a bit. But then also the height tool can be used up against one of the walls here. And when we put it in place like that, we now have a surface that is coplanar with this wall that extends all the way up to the 15-inch limit. So for example, if we're worried that this arm might be too long when it's in its longest position, that might make the robot longer than 15 inches. Here's how we would check that. I'm going to flip the robot around, actually, and I'm first going to use the height tool. This is slightly awkward to do one-handed, but we'll make it work. I'm going to set the height tool here and just bring the robot back so that it is in line. The furthest back point of the robot is just as far back as it can be. And then I'll move the height tool over here and I'll set it in place. Make sure it's snug up against there. And at this point we can move the arm through its full range of motion and make sure that it never passes the front of that height tool. And so we've verified that the robot is in size horizontally throughout the entire match. All right, so that shows how we use the compact sizing tool to size robots. Let's talk a little bit now about how it goes together. So obviously these are 3D printed parts, and they attach to a couple of normal VEX IQ field tiles. And the way they attach is with screws. So if I flip them over, you can see there are screws going into the 3D printed parts to attach them to the tile. And these are normal 832 screws, which is the same size used in V5 and EXP. So hopefully they are not too difficult to access. And what those screws go into is heat set inserts in the bottom of the walls. And I have an example piece here. So in the bottom of this wall piece, there are a series of these holes spaced 1/2 inch apart. And in the holes that are going to be used by screws, I've inserted a couple of heat set inserts. If you're not familiar with this technique, these are just brass pieces that you press into holes that are modeled to be just the right size. You use a hot soldering iron to melt the insert into place, and it forms a really nice connection, gets you nice strong metal threads in your 3D printed parts, and it's a really easy and great technique. And you can buy a 100-pack of these inserts online for just a few bucks, so it's not very expensive. And of course the end wall here has those same holes for heat set inserts. It just has to be a slightly different shape because the holes aren't in exactly the right place to make this 20 inches long. And then the height tool here is just a 3D printed part. Obviously this part's 3D printed, and then there are some VEX IQ beams to bring it up to the full 15 inches tall. There are two 2x20 beams on the outside and a 2x16 beam in the middle. And obviously they're just attached to the 3D printed part and to each other with a bunch of VEX IQ pins. And then one final detail is in the back, or on the back of the base here, there are a couple of screws. These are, again, 832 screws, I think 1 inch long, and they're just threaded directly into the plastic. And those are just there to provide some counterweight so that you can leave it sitting upright without it tipping over. So I think that is everything I have to say about our compact VEX IQ sizing tool. I will include a link to view this model on Printables if you're interested in making one for yourself. And that's it.